So our third method of solving a system of equations is solving with elimination. What do you think of when you hear the word elimination?
Getting rid of.
Getting rid of it, right? Just, it's gone. It's, for lack of a better word, eliminated, right? Okay, so when I'm eliminating something, I'm looking for the equation to be in this format, ax plus by equals c. What does that mean? That means that my x and my y term, it would be helpful for you to write this example. My x and my y, all right, so I'm just basically writing a random one so you can see. My x and my y are on the same side of the equal sign, all right? Now, think back to substitution. X or y needs to be solved for substitution, right? Do you think that that's going to be an easy feat? That's going to take some work to get x or y solved for. So obviously, if an equation is in standard form, substitution is not practical. And neither is graphing. Because with graphing, I have to have it in slope-intercept. Y equals mx plus b. You with me? So when I see an equation in standard form, and then if I see another equation under it, all right, like this, that's in standard form. Here's what I want you to notice. I'm not actually going to solve this, but I want you to notice my x's are lined up, my y's are lined up, and my numbers are lined up. This is a prime setup for elimination. Okay? But this, I need you to understand, both equations are written in standard form. So what am I looking for with elimination? I'm looking for opposites. For opposites. Now, my rule says that I can either add these systems together or I can subtract them from each other. Well, if I look at it and I see, I see terms that are the complete opposite. Does anybody see an opposite? I'll go ahead and solve this. Anybody see an opposite? Anybody see an opposite here? Do you see 2x and negative 2x? Okay. Everybody agreed those would cancel if I were to add all these together. So my rule says I look for the ones that are easily eliminated, 2x and 2x, and then I just add down the rest of it. What's 3y plus 4y? 7y equals, what's 12 plus 16? 28. And now how would I solve for y? Divide by 7. So look for the ones that are easily canceled, and then you can solve for the other variable. All right? And then, just like I did with substitution, what could you do with the y value to solve for x? What could you do with that y value? You could come back up here and plug it in. I would encourage you, if you know you're solving for x, avoid the x that has the negative with it. Okay? It just saves you a little bit of hassle. So, all right, we'll just go ahead. We're already almost done. So plug in the 4. I didn't plan on this, but, You guys following along okay? So you go back and plug in the 4. So now you have 2x plus 3 times 4 equals 12. All right, so 2x plus 12. Oh, this is interesting. Equals 12. What would you do to solve for x?
Subtract 12 on both sides.
Subtract 12 on, Subtract 12 on both sides. Well, what's 12 minus 12 on the other side? 0. So when 2x equals 0, x is going to equal 0. So then I put it together in an ordered pair, and my solution is 0, 4. All right, and that's my solution. So with elimination, I look for opposites. We're about to do a bunch of them. All right, and every question I'm going to ask you, the first question I'm going to ask you is, are the variables lined up? Okay, meaning standard form, x and then y and then my number on the other side. If it is, it's setting you up for elimination. Substitution is not the most practical because you don't have x or y solved for. Everything's lined up. Do you see an opposite? Can anybody raise your hand? When you're looking at this first system, does anybody see a set of terms that are opposite each other. Anybody see one? Allie? 3y and negative 3y. So you can solve for either x or y first. It doesn't matter. So look for the ones that are easily canceled. 3y and negative 3y. Those cancel out. So because they were opposite, that means I added the systems. 3y plus negative 3y cancels. So now I need to add everything else down. What would x plus x be? 2x. What would negative 2 plus 16 be? 14. And now how could I solve for x? Divide by 2. X equals 7. X equals 7. All right, I want to see, can you go back and plug back in for x? Now, let me ask you this. If you're solving for y, you can do either one. All right, if you're solving for y, which one would you pick? I'd probably pick the top one to avoid a negative being connected to y. But if that confuses you, honestly, guys, as long as you follow your signs, you'll get it right no matter which one you plug it back into. Okay, so try to plug it back in and see if you can find y. Now I'm going to plug back in 7 for x up here. So 7 plus 3y equals negative 2. So I subtract 7 to the other side. 3y equals what, guys? Negative 9. Divide both sides by 3. And y equals negative 3. Okay, so now what's the ordered pair together? 7, negative 3. Don't forget to put it back together. Okay, 7. And please get the order right too. If you had said 3, negative 7, that's wrong, okay? Because the x value comes first in the ordered pair.
This one way better than the
Okay, I know. Okay, so yeah, I would agree. Okay, so now let's do the second one. Let's do the second one over here. Again, I want you to see if you see any opposites. All right, when we do this lesson tomorrow, you're going to see that sometimes, even with elimination, it needs a little bit of work, okay? But see if you see any opposites here that you could cancel, bring the rest down, and solve. I just want to see if you can get started. Break the ice, if you will, okay? What did you cancel, Josh?
In that one?
Yep, on the second one.
Negative y.
Yep.
Positive y.
Did you guys cancel your y's? Your negative y plus y? Did y'all cancel DH? Is that one the one you did? Okay. So because I saw opposites, I'm adding my systems because I add to cancel opposites. So that means I need to add the other terms. So I get 6x equals 30.
Wait, what?
And then you divide.
2x plus 4x is 6x. 9 plus 21.
I did that one.
We just did.
We just did that one.
We did?
Yeah.
We just did that one.
Oh, I did x plus 3y equals 5.
Okay, so then you divide both sides by what?
6.
6, and you get x equals what, guys?
5.
X equals 5. Who got 5 for x? Who got x equals 5?
Oh.
Anybody get x equals 5? Okay. Now what did you do to solve for y? Like, how'd you solve for y?
Okay. Alright, I solved for one. So I use 2 times 5
Okay.
minus y equals 9.
So 2 times 5 minus y equals 9.
Okay.
So
Then multiply, made it 10, negative y equals 1. Then I did minus 10, so it equals negative 1 on both sides. So negative y equals negative 1. Then you divide it by 1,
Yep.
and it equals 2, negative 2.
Well, you literally did everything perfect. 1 divided by 1 is 1. Okay, now look up here, guys. 10 minus what is 9? What's 10 minus what equals 9? 1. 1. So if some of this, I don't, you're going to find with elimination, it might be as simple as once you multiply, could you just ask yourself 10 minus what number would equal 9?
Yeah.
If you get y equals 1 without all the work, that's okay. All right? I'd be totally fine with that.
So
5, 1.
Yep.
5, 1. Okay. All right. Great job explaining that too, Nick. Okay. I want to do one more. One more for today. Okay. So let's do this first one. All right. You see, I put a ton of practice problems on here. Okay. A lot of practice problems, but you should see a common theme. Are you seeing something common?
Yes.
Kind of coming up with all of them. The first thing you do is look for the opposite variables to cancel, bring the rest down, solve, and then go back and plug it in. Michael, which one did you cancel first? Okay. Canceled out. Did everybody else cancel your x's first?
Yes, ma'am.
Okay. And then what did you bring down?
I write down 2 negative, no, not negative, but positive 2y.
Uh-huh.
And then it equals 2.
Yep.
And then y equals 1.
Yep.
And then after you do that, you go over there to the complex and you plug in 1 for y.
Uh-huh.
And then
And then,
x plus 3 equals 5.
yep.
Wait.
Oh, I still got it.
Minus 3.
You did the other.
Yeah, he did.
That's okay. And x equals?
I told you.
X equals 2. Okay, so hold on. So 2, 1 is my ordered pair. Now I heard someone say that they plugged it into the second equation. Did you get the same answer? Okay, so there's the proof right there. They got y equals 1, but they plugged it into the other equation, but they still got the right answer. Okay? So as long as you do the math right, it doesn't matter which one you plug it back into. Who got 2, 1? Who got 2, 1? Okay, I would say pretty successful for the first part of our lesson today. We still have more practice to do. We're going to finish up elimination tomorrow, and then we're going to bring back in our other methods, graphing and substitution, and start to kind of look at these systems from other perspectives. But you've officially been introduced to all 3 methods now. Okay, so that's where we'll leave off for today.